Hello, can you hear me? Hello, hello, can you hear me?
Yes, we can.
Okay, if you can, then inshallah we'll start our lecture now. What is our lecture? Chapter number 3, chapter 4, 5, we will start. Okay, we start our chapter. All right, Bismillah. So we start now here. Can you see the screen? Can you see the screen? Please let me know. No. Yes. 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 All right. So yesterday we are where we studying. Yesterday we did this. Now we are where yesterday we learned here, right? Activity diagram. We learned lots of things. Then all right. So we are doing the example 5.5. There is a beam with the roller and hinge. Here, this is the hinge and this is the roller. That's we discuss it, and then I draw the free body diagram. Free body diagram. This is also still available here, right? Free body diagram. We draw it there. And what is this? Next class we start it, and then now okay. Now today we will try to solve the problem. We will try to solve the problem. We'll try to solve the problem. Okay, what's the problem? Problem is this. Let me prepare a new slide, and you're going to help me. 27 students only. Okay. First, you have to draw the free body diagram. First, you have to draw the free body diagram, and let us draw. Let us draw it. Okay, sorry, it's difficult for me to draw a straight line, but I try. I try. So what's happening there? Why? Okay. So this is our beam, and when we draw freehand sketching, we show hinge like this, and we show roller like this in freehand. But in picture you can see in the book, in picture the hinge they show like this. Okay, there is one nut and bolt. This is the actually hinge, and roller is like this. Okay, this is roller in a picture, but when we draw in the free body diagram, then by hand, then this is the hinge and this is the show like this. Okay, now what are the force we have? We have D force 100 Newton at point D, and each is 2 meter distance. In exam you need to draw the freehand, right? You must have to draw actually freehand drawing to show me that how you're solving. Without free body diagram you cannot solve. 2 meter. So, and one force is working here. I showed you before in inclined force, and it has to be divided in two components, right? Divided into two components. So divided into two components. One is like this, and it is 600 sine 45 degree, and another one is actually working on the surface, this surface. There is a distance. There is distance between these 2 points. You see that here is the distance. What is the distance? And this distance is written there in the picture. This is how much? 0.2 meter. 0.2 meter. This is important. This is very important. 0.2 meter. Most of the students do the mistake here. So here this 0.2 meter distance between this. Here 600 cos 45 degree, right? Can you someone calculate and tell me how much 600 sine 45 degree? Please calculate and tell me. There is another force here, just this point. This point is force is 200 Newton. 200 Newton, right? Now maybe we don't know this. We can delete this, draw everything. This is 45 degree. Now, okay. Now let's draw. Let us delete. Can you please tell me sine 600 sine 45 degree is how much? How much the price? How much the force magnitude? All right. Now look. Now what is the question? Question is written is the horizontal vertical component reaction. Horizontal vertical component of the reaction, right? Now before you start your problem, you need to know the how many unknown you have. In this total problem, you must have to know how many unknown you have. You must have to know this. How many unknown you have. So find unknown. So we know the roller will give only one reaction, and it is one reaction. It is R. This point name is A. This is B, and that is B. This is C. Suppose this point name is C, and this is D is given. So RAV, right? One unknown, and we know that. What we know? We know that the hinge support will give us two reactions. Hinge support give us two reactions. So one will give vertical reaction. One is vertical reaction RB into RBV. RBV means vertical reaction. All right. And another reaction will work where? Another reaction will be working at this point. at these points, horizontal and vertical, horizontal and vertical, RBH. Now they ask the, so our question is, what is this value, what is this value, and what is this value? Yesterday I think I wrote down something. Yes, RB, RBH, and they are, what is the values? Okay. Okay. Now, and we have three equation. We have three equation: summation of FH, summation of FV, and summation of moment. We have only this equation to solve this unknown. Okay, let's start with the summation of horizontal, summation of horizontal force. Summation of horizontal force. When you write down, you declare which direction you are assuming positive, right? We are assuming this right hand force is positive, right? Positive direction. So in positive direction, what are the force we have? What force? Look, this is vertical force, so it will not come. Here we have horizontal force is 600 cos 45, right? 600, only one horizontal. This is vertical, this is also will not come. This is vertical, this also will not come in the counting. This is also vertical, this is also vertical, this will also not come. Only we have this, right? So we assume this right hand side force is positive. So it is we assume this is left hand side. Okay, now one thing is, I tell you, the unknown, one is unknown, but what will be the direction of unknown force? What will be the direction of unknown force? I tell you, like when we are doing when unknown force means this force unknown, we don't know the value of this force, we don't know. Sorry, wait for automatically saving, so it takes some time. What is happening? He's gone, then coming back. Okay. So it's record. Pin. Right? These are unknown force. Now, at the beginning of the problem, when you decide problem, because you don't know unknown force, right? You don't know value of the unknown force. You don't know. So what will be the direction? Direction is this side or this side. Direction will be this side or this side. How do you know? Because you don't know. You assume anything you want. So we assume the unknown force RV will be upward, and unknown RV will upward, right? And unknown force of RVH is leftward, right? If you want, you can assume rightward, no problem. I will show you. I will show you the example now. Please be careful, and this is very important. So be careful. So here, see, the only horizontal force 6 cos 45 degree, and on another is 6 cos 6. Another force is RBH, and it is because left side, so it is minus RBH. There is no other horizontal force, so we can write equal to 0. Then RVH is equal to how much? Please calculate and tell me how much the RVH force. RVH. Calculate it and tell me, please. Sorry. Okay, now you can hear me. I can hear you. Yes. Look, what I'm telling you. You, because there is a horizontal force here, horizontal reaction. Now, because it is unknown reaction, so we don't know it will be right side or left side. We don't know. So you have freedom to choose anything you want. You choose anything you want. After that, you can change it. As example, if I tell you, as example, first we look first. First we choose, okay, our unknown force is left side. Okay, if so, so this force is positive direction, this force is the positive direction, and this force is negative direction. So we write down negative minus. So we got the result RBH equal to how much? 400. Someone paid me 424.26 Newton or kilonewton, something, right? Newton or kilonewton, anyway, Newton, right? Now, but you have freedom, unknown force. If you want, you can select your unknown force is right side, rightward. Then what will happen? At the end result will be same. How? I show you how. If you select right side, so the force, this is the plus 645, 645. Sorry, 600 cos 45 degree, and I remove this 645, and then this force RBH, now it is plus sign, it is horizontal plus sign. Okay, plus sign. If we do the calculation, so RBH equal to, now result will be minus 242.24.26 Newton. Now look, now our result become with minus. Now our result will become minus. Because result is minus, that means our assumption is right side was not correct. It is the not correct. So correct answer will be actually actually leftward. Okay. So what we'll do, our result will write down like this: RBH. Now we will omit this minus sign, 2,4H and 2 Newton, and we write down like this. Okay. Result is that side. Okay. That means the RBH. Can you repeat the direction? What do you mean by Hossein? What is your problem? Tell me please. Hossein. I am telling you very important thing. I told you very important thing. If you are not attentive, you are going to miss big thing. Sign, negative or positive. Look, very careful. I am starting from the beginning. Okay. Become very careful. Complete from the beginning. Look, we have very short time. Within a short time, we have to finish it all the thing, right? I remove all. If you are not attentive, you are going to miss lots of things. Very important thing, right? First, I write down again. Be careful again. Oh, come on, now this doesn't work. First, you see here. First, you have to know how many, as I told you, how many unknown you have. You have how many unknown, and also you need to know how many unknown. Here, how many unknown? Here, unknown you have are why doesn't work. So it become hang again. Sorry, just you need to please wait for some time. Now, again, the problem is sometimes the computer become hanged, so we have to repeat again, repeat the things. So I repeat and I tell you, right? From the beginning, I will tell you from the beginning. So you need to know how many, again, how many unknown. So here unknown is, one unknown is RV, RAV, vertical direction. Another is REV, vertical direction. Another is VS, vertical direction. Now, reaction, when you see vertical reaction, so vertical reaction is unknown. It is unknown. We don't know the magnitude. We don't know what, we don't know magnitude, and we don't know also direction. We don't know what is magnitude, what is direction. We don't know, right? So magnitude we will calculate. Direction, okay, I assume direction is, what is direction? We assume any direction. We assume any direction. Okay, we will assume any direction. If our assumption, I'm writing down very quickly, but you must have to note down. If our assumption is correct, the result will be positive. If not correct, then result will be result will be negative, right? If negative, then what we have to do? If negative, what we have to do? If negative, then we have to change the direction. Okay, write down this thing, very important. You will not find in book, any book, what I am telling you. First is magnitude we will calculate, but direction we will assumption. If our assumption is correct, then result will be positive, so we don't have to do anything. But if not correct, assumption is not correct, then result will be negative. If negative, then what do we do? We have to change the direction. I will show now a example. Okay, the example I will show you now. Look, I am running out of time. We have to finish lots of things. We need to draw it again, sorry. So this is our beam, this is this is 600 sine 45, 600 cos 45, and here is how much? Tell me please. 100, and here is 200. Here is a hinge, and here is a roller. In roller, now RV, vertical. Now, so as I told you, we can assume upward or we can assume downward because we don't know. So we assume it is upward. Okay? Here RV, RBV, we don't know. So we assume it is upward, right? Here it will work at suppose the horizontal RBH, horizontal force. It could be left side, it could be rightward, it could be leftward. Okay, we assume leftward, right? We assume it is right side, RVH, right? Then we are going to here is 20.2 meter. Okay? Now we are going to solve it. Okay, so summation of horizontal force equal to 0, and we assume all right. If it is the rightward force, that we will assume it is positive. So here horizontal force is 600 cos 45, because it is right side, right direction, so here positive. Okay, then this is, there is no vertical horizontal force, right? This is vertical, so it will not come in calculation. It is vertical, not come calculation. It is vertical, not considered. So we have only one more horizontal force, this one, and this force is right direction, so right direction is plus, so RVH, and there is no other horizontal force, so equal to, we will write down equal to 0. Now we write down RVH equal to how much? So it is, tell me the calculation, tell me how much, tell me quickly. It is correct. 2 4 2 to 4 or 2 to 4. Do it again, please. Hussain Ali Ibn Hussain, do it please again and tell me. Okay. So plus or minus Ali Jawad Ibn Haji, tell me plus or minus. Tell me plus or minus. Plus. How come it's plus? How come from this equation the result is plus? Tell me. Hussain Ali Ibn Hussain, Alawi. Tell me correct result. If you move the RBH in the other side, it will be negative. I did not ask is that question. I asked the from the course it is negative. Yes, it is negative. So what is the result? So it is negative, right? So it is minus. Minus result is 42426 Newton, right? Now, as I write down there, what we wrote down there, remember what I wrote down? If result is negative, right? If negative, we have to change the direction. That meaning is it is negative result. That means we need to change the direction. Yeah, change the direction. This we assume it is right direction, right? The force is working right direction. So actually the correct, that means meaning is our correct answer will be, it will be 4 to 4.26 left direction. This is the correct answer. This is the correct answer. In exam you write down this way, and what you have to do, and you delete it and write down the correct direction. What is the correct direction? Correct direction is this. Okay. Now understand how you have to do it. Clear or not clear? All right, right? Are you okay with this? Okay, today banner is not working. I'm sorry. So there, I don't know. There will be there is no attendance. Okay. Could you please answer me? Are you okay with the clear? Are you clear? Okay. Now, all right. So this is where you solve the problem, right? This is the way you solve the problem, right? Now we know the result of the one result. We already got the one result. This is 424.26 Newton. Now we will do another problem. We'll do another problem. So here this distance is 2 meter and this distance is 3 meter from here to here, and this distance is 2 meter, right? Now we need to find RAV or RBV, right? Now there is two unknown. So we first take the moment at B. This is the point B. Moment at B. We take the moment. Summation of moment at B. And we assume the anti-clockwise is positive. We assume anti-clockwise is positive, and we will take the moment at B. Now if you take the moment, so how many force we have there? We need to consider. You see, we will moment is, what is moment equal to? Moment equal to force into distance. Force into distance is the moment equal to force into distance. You already know moment is equal to force into distance, right? So here, how many force we have? We have RVH, okay, force. We have RBV. Then we have 100 force. We have, sorry, first we write down. We have 200. We have 200, right? Then we have 100. All the force I write down. All 100. Then we have what force? We have here two forces. 6 sine 45 degree. And another force we have 6 cos 45 degree. And we have another force RAV, right? These are the force we have. Now we find the force. We write down the force, right? Now we need to find the distance. Now when is B? So at that same point, this is RVH. So there is no distance. So distance is into 0, right? Plus. So plus B at the same point. So RV, there is no distance. So distance is into 0, right? Plus then plus 200, right? 200 and RV is the same point. So there is no distance. So distance equal to 0, right? Actually, this all force is 0. We can cancel it out straight away. Now what we have? We have 100. So what is the distance with 100? 100 distance is 2 meter. 2 meter is distance. All right. Now question is, with respect to point B, the 100 meter is rotating clockwise or anti-clockwise? Can you place clockwise or anti-clockwise? It is rotating anti-clockwise, so it is plus. Then we have another force is 600 sine 45 degree, right? It is also rotating with respect to B, is anti-clockwise, so it is also positive. But distance, what is the distance? Distance is from here 2 meter plus 5 meter. So distance is 2 plus 3, total 5. Now we have another force. What is the force? We have force is 600 cos 45 degree, and with respect to point B, it is actually rotating clockwise, so it is minus. So it is minus. Here we write down minus. And what is the distance? The distance is from this point is, this point is point 2. This point is point 2. This point is point 2 minus 0.2, right? Minus 0.2. Then what else force we have? We have the RAV. So RAV also rotating positive direction. So RAV also minus into, what is the distance? Distance is 2, 3 plus 2. So 2 plus 3 plus 2. Now there is no other force we have, so equal to all equal to 0. Now here we have, here what we have, here what we have the only RAV is the only RAV is the unknown. So please try and tell me, do the calculation and tell me what is the result now. Okay. Point 2, 0.2. How 0.2? So the diagram become very clumsy. I tell you, please ask him, Hussain Jawad. Diagram become very clumsy. So I draw it again. I draw it again. Here, okay. Remember, our beam is actually like this. Okay, our beam is like this. So here is dotted line, and some point here we have vertical force 600 sine 45 degree, and another force I draw in another color at this point 600 cos 45 degree, right? Now the distance between here, we are taking moment at point B, right? We are taking point at B. B is here, okay? B is here. So our RVH okay, here. Here also RVH into 0, okay, right? So we are taking moment here. So distance between this distance will moment, this distance, and this distance is given 0.2 meter. So that's why I write down 0. Here, Sanjawad, 0.2 meter, 0.2 meter again. So the distance is, so I write down more clearly here. I write down, it is not clear there. It's not clear. It is not clear. So I write down there is minus 600 cos 45 degree into sorry, 600 minus into 0.2. Right, now this solve the problem, please, and tell me the result. Okay, if you calculate, you will find the result 319. If you calculate 319 Newton, right? You calculate, if you find 319 Newton. So we got two results. We got RVH, we got RAV we got. Now third result, how can we get the third result? How can we get another result? Now we apply. So this is again, this is our beam, this is our beam. Here RVH equal to 424 Newton, and RAV equal to 319. If you calculate, you will get it. Now, and then here you have vertical force. So 600 cos 45 degree and 600 sine 45 degree, right? And here we have one force 100, and here we have one force 200. Now we don't know, only this force is unknown, only this is unknown. How can we get it? Very easy. Suppose we take the summation of vertical force. Summation of vertical force is 0 and upward is positive. We assume upward is positive. So this force we assume the upward, right? RAV. RAV is upward. Okay, plus. Then this force is minus. Okay. So RAV here RAV is upward, so plus, and RAV value is 3319. Okay, then this force is downward, so negative 600 sine 45. Okay, then minus, this is also downward force, so minus 100, and this is also downward force, so this is also minus 200, and only we have this one upward, so plus RVB, and then there is no other force, so it will be 0. Now we have only one unknown. Now we have only one unknown, RVB. Please calculate and tell me the result. And if you calculate, you will find the result is 405 Newton. Okay, this is 405 Newton. All right. Okay. So if you have any question, please ask me. You can ask me. Now,
Doctor.
yes.
I have a question in chapter 4.
Chapter 4. Yes, tell me.
An example 4.8.
Yes, tell me.
In the example, they take the f without multiplying by the UAB. Why here?
Let me check. You open the example 4. You're talking about which one? 4.8.
Yes.
This one, right?
Yes.
Yes, tell me what's the problem.
The f 300.
Yes.
Should we make it in a Cartesian vector, then put it in the matrix?
Sorry, you
make it in Cartesian vector?
Yeah.
Then we put it in the matrix.
Yes, you have to do it. So it is actually yes. F300, 300. It is F300, right?
Yes.
Newton. It is a scalar value. But if you say it is vector, then it will be minus 300k.
Okay.
And it is
here.
It has been done there. It is done there. Somewhere we have done it, right?
Why we don't multiply it by UAB or UAC?
You done it. You see, it has been done it here. You see, it has been done here. Okay. F, and this is actually U. This is actually UCD multiplied by. But because it is directly straightway downward, right?
Okay.
So actually, without this calculation, you can do it. Even without calculation, you can write down. Because downwards, so minus 300 is the magnitude. So, and we know for x it is I, for j, for y it is j, and for z it is k, right? So it is
yes.
z direction. So just write the k. But if you say that no, I don't understand this, so follow this procedure. Follow this procedure.
Yes, I think that's better because it's the original one.
Yes, follow this procedure. It will give you same answer. No problem. You know?
Yes. Thank you, Doctor.
You're welcome. Then any other question?
For me, no. Thank you.
Okay. Any other student? Any other question you have? So someone has question. Just a moment. Oh, thanks. Okay, fine. Anyway, still you can ask me. Can we leave? Yes, you can leave, and you can leave because the today is not working. The banners, I cannot give you the attendance. I will give attendance to all anyway. So you can leave. You can leave if you don't have any question, right? And remember, you have exam today at what time and what places. I send you email, right? The question, 1 hour. I tell you the question from each chapter, one question. Chapter 2, chapter 3, chapter 4. And I suggest you do the good practice. Do the one, there is no question from one. Do the good practice, and you must have to know how to use the calculator. Right? Chapter 2 one question, chapter 3 one question, and chapter 4 one question. And you need to know how to use calculator for the solving the problems. Right? I told you in the class, remember that you learn how to solve the simultaneous equation, how to solve the XYZ, right? Using your calculator. In exam question, in exam, don't ask me, doctor, how to solve it.
Doctor?
You have any other question?
Doctor?
Or we can leave the session.
Doctor?
Yes?
Chapter 4, 4 to 4.8. That's it.
Yes, up to 4.8. I tell you again, I tell you chapter 4, up to this here. You can see the screen?
Yes.
33, up to slide 33.
Okay.
All right?